Hello everyone, I would like to welcome you all in our next video. Here also we are going to talk about the exponential equation. In our two previous video, we had talked about the exponential equation. There were various axioms. We discussed about that, and even under those axioms, we talked about few questions that how can we solve the exponential equation. So, continuing the same thing and adding some more new examples. Now, today we have arrived at day 3. So here also we are going to talk about some of the new example questions of exponential equation. Okay, everyone. So without this wasting our time further, let's go to the question part. All right, everyone. Solve question number 1. So you can see one question here. There is 2 to the power 3x minus 5 times e to the power x minus 2 on the left hand side, whereas on the right hand side 2 to the power x minus 2 times a to the power 1 minus x. Now, this question seems a little bit different than the question that we had taught in our previous classes. So now we have to use a certain different idea while we are solving this question. So everyone, now let's move ahead. As you can see here that there is 2 to the power 3x minus 5, and on the right hand side also you can see the base 2 containing term. Similarly, there is a containing term on the right hand side, and there is also a containing a base terms on the left hand side. So due to that reason, and due to there is no any kinds of plus or minus sign in between the basis terms, so what we are going to do is we are going to take either left hand side whole to the denominator of right hand side, or right hand side whole terms we are going to take to the denominator of right hand side. So either of the thing can be done. So I'm just taking one idea. That means I'm going to take all the right hand side terms to the denominator of left hand side. But as I told you earlier also, all the left hand side also could be taken to the denominator of right hand side. Okay, so now you can see here that I have taken all the terms of the right hand side to the denominator of the left hand side. Now going further, to make us easy, to make us distinguishable, I have just given a different color for a base containing term and black color, the same black color for the base 2 containing terms. Now, we know that in case of this format, as you can see here, in this format, there is product sign in numerator case and in denominator case as well. So due to that reason, we are easily allowed to use quotient law. Yes. So while we are using quotient law, we have to use quotient law separately for base 2 containing term and that separately for base a containing terms. So when we use the quotient law in case of base 2 containing terms, the denominator, this 2 to the power x minus 2, will go to the numerator. Yes, according to the quotient law. But while they are going up, the uh, the sign of the power will be changed. That means the plus x will be changed into minus x, and minus 2 will be changed into plus 2. That's right. And similarly, that the same thing will be applied in case of base a containing terms also. There is power x minus 2 on the numerator of base a, but look at the denominator. Base a has power 1 minus x. So when this power goes up, and according to the quotient law, their sign also will be changed. 1 will be plus 1 will be minus 1, and plus x will be minus x. So the same thing you can see here. Okay, I think by seeing also you can understand. I have taken the denominator basis to up using the quotient law. So x minus 2 has been changed into minus x plus 2, and 1 minus x has changed into minus 1 plus x. So this is according to the quotient law. Now, so as we can see the like terms in case of power, so plus 3 and minus x, plus 3x and minus x, they can be simplified, and minus 5 and plus 2, they can be simplified. Similarly, plus x and plus x, they can be taken together and simplified, and minus 2 and minus 1 also can be simplified further. So 3x minus x will give us 2x, whereas minus 5 plus 2 will give us minus 3. That's right. Similarly, in case of base a, there is x plus x and plus x. So it will be 2x and minus 2 and minus 1, it will be minus 3. So the same thing you can see in this next step as well. Now going further, here is 2 to the power 2x minus 3 and times there is a to the power 2x minus 3. So that means they both have same powers. Those bases are different. There is base 2 and there is base a, and in between them there is product sign, multiply sign, but their powers are same. So there is one rule, one product rule, power rule that we can apply here. That means if there is x to the power a times y to the power a, then it can be written as xy whole to the power a. That means according to power law, both bases can be taken together in terms of multiplication form, and their power can be taken common. That means we can write a single power in terms of that. But it is only applicable in case of product sign in between them and or division in between them. Okay, in case of addition and subtraction we cannot do. Just like for example x to the power a we have and plus y to the power a. If we have like this, then we cannot do we cannot do x plus y to the power a. So we need to be aware about this. Okay, they are not same. I have shown you two examples also. They are not same. All right. So now going further in our question that we have been discussing, there is base 2 and there is base a. Even though they have different base and there is product sign, so we can take them together, that is 2a, and we can write whole to the power 2x minus 3. So the same thing you can see here. So what I have done here is I've just taken the bases together, a and 2, that is 2a, because of being multiplied sign in between them, and instead of 2x minus 3 and 2x minus 3, I have written the single power as a by taking common 2x minus 3 equals to 1. Now as we are actually looking for the value of x, so now let's think further, like how can we go ahead? Okay, if you think precisely, then there is 1 on the right hand side, isn't it? So some of you might have started to think that is it possible to write 1 in terms of base 2a? Exactly, yes. This 1 can be written as 2a whole to the power 0, because according to the zero law of indices, 2a whole to the power 0, the value of 2a whole to the power 0 is 1. Yes. So due to that reason, now on the right hand side, we are going to write twice a whole to the power 0. Because according to zero law, the value of twice a whole to the power 0 again becomes 1. So now, by using the axiom of exponential equation, now we have arrived at this stage to share that we have arrived at this stage that there is 2a base and there is also 2a base. That means both bases are being same. So we know that if both bases are being same, then according to the axiom of exponential equation, we can equalize the power. That means 2x minus 3, this power of left hand side will be equals to the right hand side power, that is 0. So therefore 2x minus 3 equals to 0. So now as we are looking for the value of x, so 2x will be equals to 3, and finally the value of x equals to 3 by 2. So in this way, we can solve this question number 8. I hope that you have understood the idea very precisely. Now let's move ahead. Now let's go to the next question. This B number question is also very much similar with question number 8. So let's try to find out some idea. Now, like in case of previous question, there were base 2 and base a, but here is base 5 and base 3 on the left hand side. But if you look at the right hand side, there is a single term that is 225. Now let's think for a while, how can we move ahead? Of course, yes, 225 can be broken down, isn't it? So when we break down 225 into the prime numbers, that is 2, 3, 5, 7, and so on numbers, then yes, of course, 225, if you see here 225, you can do it through your calculator also. If you try to factorize 225, Then let's take the first number is 3. 3, 3 sevens are 21. Yes, 1 comes here. Then 3 fives are 15. So again, it can be further factorized by 3. So 3 twos are 6. 1 carry over here, 15, and 3 fives are 15. Now it cannot be further factorized by 3. Now let's take the next prime number, that is 5. 5 fives are 25. Now as 5 itself is the prime number, so it cannot be factorized further. So that means, can we write 225 as a 3 square times 5 square? Obviously, yes. So the right hand side 225 whole terms can be written as 3 square times 5 square. Now, it is very much similar like the previous question. Yes. So to understand and to make the calculation easy, I have given red color to the base 3 terms. I have kept the same black color for base 5 containing terms. So like in previous question number 8, let's do the same thing here. That means either we are going to take all the terms, all the left hand side terms to the denominator of right hand side term, or all the right hand side terms to the denominator of left hand side terms. Okay. So here also I have done the same thing. That means I have taken all the right hand side term to the denominator of left hand side term. So the same thing you can see here. All right, everyone. So now see, so as I have taken all the right hand side terms to the denominator of left hand side term, there will be one remaining on the right hand side, because I have not taken the terms in the form of left and right. Okay, I have just taken them in terms of reverse of cross multiplication. That's why there will be one. Okay, in case of left and right and shift, there will be 0 remaining if none of the terms are remaining on that side. But in case of reverse cross multiplication, there will be 1. Now if you see the left hand side terms, there are so many terms, as you can see here also. But now precisely seeing, there is base 5 containing terms, and at the denominator also base 5, and the denominator there is base 3 containing terms, and the numerator also base 3 containing terms. Yes, now again we can use the idea of quotient law. So when we use the quotient law, the denominator terms will go to the respective numerator terms, and by changing their sign. Yes, so the power 3 of this denominator 3 will be, base 3 will be, power plus 2 will be minus 2, and similarly base 2, this base 5's power 2 will, when it goes up, it will also be, its sign also be changed. That means it will be minus 2. So the same thing you can see here. Now moving ahead, when you simplify the respective powers of base 5 and base 3, then there will be x minus 3 minus 3 minus 2 becomes x minus 5. Similarly, here is 2x, and here is minus 8 minus 2. That means minus 10. Yes. So now we have arrived at the step of writing 5 to the power x minus 5 times 3 to the power 2x minus 10 equals to 1. Now let's think a while. In previous question, if you have remembered, both power were same after simplifying them. But this time, if you see here, the power exactly in front way, or if we just see it, it does not look same. But if you go inside, if you see the things precisely, there is x minus 5 and there is 2x minus 10. Yes, that means if you take out 2 common from here, from the power of 3, then there will also be remaining as x minus 5. Yes, so that means there is 3 to the power 2x minus 10 is there. So in case of power, if we take 2 common, then the remaining will be x minus 5. Okay, so now we know that according to power law, it can be written as 3 square whole to the power x minus 5, isn't it? So easily it can be written like this. So that means 3 square can be written as 9 also. Yes. So 9 to the power x minus 2 also can be written. Okay. So now the same thing you can see here. For our easiness, I have kept the same base. That means after taking out 2 common from the power of 3, I have taken that 2 inside by using the power law. Because we know that when we simplify this term, again upper term can be obtained. Now, see, there is 5 to the power x minus 5, and there is 3 square, that means 9 to the power also x minus 5. That means both terms are having the same power, and there is product sign in between them also. So similarly, here also we can apply the idea of power law. Yes, so that means 5 times 3 square whole to the power x minus 5 equals to 1. So simplifying further, 5 times 3 square, yes, it will be 45. So 45 to the power x minus 5. And as usual, but to use the axiom of exponential equation, the right hand side 1 can be written as 45 to the power 0. Now, by the help of axiom of exponential equation, we can equalize the power. That means x minus 5 equals to 0. So eventually, x equals to 5. So this is how we can solve this B number question. Now let's go to the next question. C. In question number C, as you can see here, there is 7 to the power 2x plus 3 times 5 to the power 2x minus 1 equals to 7 by 5. Now, coming at this point, after discussing about question number A and question number B, I hope that you guys are quite clear about how to solve these kinds of questions. And I think some of you have experienced that also. These questions are somehow different than the question that we have discussed in our previous classes. Okay, so now let's move ahead and let's try to find the answer in case of this question number C also. Now look at the right hand side. There is 7 by 5. They are the prime numbers which cannot be factorized further, isn't it? Now let's do like this. Can we just cross multiply this 5 because it is in the at the denominator of left right hand side? So we can just cross multiply 5 on the numerator of left hand side and 7 to the denominator of left hand side, isn't it? So, and when this 7 and 5 goes to the left hand side, by doing cross multiply, the right hand side will be, yes, there will be 1 remaining. Okay, so to make us easy and to understand the term clearly, this I have given base 5 containing terms as a by blue color and the base 7 containing terms as it is. Now, when this 7 by 5 we have taken to the left hand side by doing the cross multiplication, now the right hand side will be 1. Now, we are quite familiar that what we are going to do, there is base 7 and there is base 7. So of course, yes, we can use quotient law here. And in case of base 5, which law we can use? Of course, we can use the idea of product law. So when we use the base quotient law in case of base 7, now you see here that in case of this denominator 7, there is power plus 1. So when it goes up, it will be minus 1. Yes. So the same thing you can see in this next step. 7 when it has come up, it has become negative 1. So 5 to the power 2x minus 1 times 5 has remains the same. Now let's take the product law in case of base 7 separately and in case of base 5 separately. So when we use the product law, now we know that there will be 7 to the power 2x plus 1 minus 1. And in case of base 5, there will be 2x minus 1 plus 1. That's good. So it will be like this. So we know that in case of when we simplify, plus 1 and minus 1 will cancel, and minus 1 and plus 1 will cancel. That means there will be 7 to the power 2x times 5 to the power 2x equals to 1. Now we have been discussing this idea so many times that if there is product sign and even though the bases are different, yes, so we can take the power formula by keeping the base terms together in case of multiplied form. So we can write 7 times 5 whole to the power 2x equals to 1. Now let's look at the left hand side. There is 7 times 5. Yes, this is 35. So 35 to the power 2x. Now if you look at the right hand side, there is 1. So can 1 also be written, or can 1 also be possible to be written in terms of base 35? Yes, it can be written as 35 to the power 0. And now by using the axiom of exponential equation, as the bases are same, we can equalize the power. So that means 2x equals to 0. Eventually, we have got the value of x as a 0. That is 0 by 2, which is simply 0. So in this way, we can solve this question number C as well. Now, we have arrived at discussing some review questions. So I would request you all, and I would like to give you, I would like encourage you all to attempt all these four questions from your side. Okay, these are very much similar questions that we have discussed in our today's class, and this F and G questions particularly are related with our previous question. Okay, previous class question. So as I know that you, so many of you have already gone through the previous video, so I think you can do these two questions with the help of the idea that we have discussed there. So all the best, everyone. I hope that you will do it in a very clear way, and you'll understand the core idea of this exponential chapter. Thank you so much. See you in the next video.